A stunning and unexpected discovery by the James Webb Space Telescope has captivated the attention of scientists and enthusiasts around the globe. While methodically scanning the distant reaches of our galaxy, the telescope detected something that defied conventional understanding: unusual light patterns, reminiscent of artificial urban illumination, emerging from a region located approximately 7 billion kilometers away from Earth. These lights appeared to originate from Proxima Centauri b, a rocky exoplanet orbiting the red dwarf star Proxima Centauri, the closest known stellar neighbor to our solar system. This startling find has reignited deep-rooted questions about our place in the cosmos and whether intelligent life could exist elsewhere in the universe. The lights observed on Proxima Centauri b weren't just random bursts of radiation or naturally occurring reflections. What made them so extraordinary was their pattern and consistency, resembling the structured glow seen in cities on Earth when viewed from space. Scientists quickly realized that these weren't just anomalies. They were potentially signs of a civilization capable of generating and distributing light across its surface, much like we do here on Earth. If this is true, it would mark the first ever indication of intelligent life outside our planet, discovery that would rewrite our understanding of biology, evolution, and the uniqueness of Earth. For generations, the idea of intelligent extraterrestrial life has existed on the borders of science and imagination. Humanity has long searched the stars, listening for radio signals, analyzing planetary atmospheres, and building powerful telescopes to peer deeper into space. Every potential clue, no matter how small, has been met with enthusiasm and scrutiny. But until now, no evidence has hinted so clearly at the possibility of artificial structures or technology in the vast void of space. The light detected by the James Webb Space Telescope is unlike anything we've seen before, a luminous fingerprint possibly left behind by an intelligent species. NASA scientists and engineers are now poring over the data, eager to understand not just what the lights are, but how long they've been there. It's a haunting thought. Could these lights have been shining for centuries, maybe even millennia, waiting for humanity to advance enough to finally notice them? One of the leading voices on this subject, astronomer David Kipping of Columbia University, has emphasized the significance of Proxima Centauri b's thermal and optical patterns. According to Kipping, the exoplanet demonstrates unusually complex heating characteristics that distinguish it from other known rocky planets. Rather than absorbing sunlight and re-emitting it in standard infrared wavelengths, Proxima Centauri b shows unexpected thermal behavior that could suggest artificial energy usage on its surface. What makes this observation even more exciting is the James Webb Space Telescope's unique capabilities. With its advanced sensitivity to infrared light, the telescope can detect even the faintest glow across unimaginable distances. It operates within a frequency band that's up to 1,000 times narrower than ordinary starlight, allowing it to filter out stellar noise and focus on subtle signals, like those produced by potential city lights or power grids on distant worlds. This technological precision has enabled scientists to begin mapping the day and night sides of Proxima Centauri b, identifying stark contrasts in brightness that may hint at complex surface activity. Observations suggest that the exoplanet might have solar arrays or other energy-harnessing technologies on its sun-facing side, while its night side remains cold and dark. The planet's ability to regulate such extreme temperature variation is curious and leads scientists to speculate on the presence of an atmosphere or perhaps even artificial climate control. Proxima Centauri b completes a full orbit around its star every 11.2 Earth days, a fact that conveniently aligns with the telescope's orbital path, giving researchers recurring windows to observe the planet's surface and atmospheric shifts. In fine detail. As exciting as the lights are, they represent only one part of the puzzle. The next major step in assessing Proxima Centauri b's habitability lies in analyzing its atmosphere. Scientists are especially interested in detecting specific gases: oxygen, water vapor, methane, carbon dioxide, and ozone, which are considered biosignatures, or indicators of potential life-supporting conditions. These elements, particularly, when found together in the right concentrations, could point to biological processes at work. However, capturing this data is extraordinarily difficult. It involves analyzing the faint light that filters through the planet's atmosphere during transits across its host star, a task that requires immense precision. While the James Webb Space Telescope excels in characterizing many of these atmospheric gases, it does face some limitations. It is exceptionally good at identifying water vapor, methane, and carbon dioxide, but its sensitivity to oxygen, one of the most promising signs of life, is limited. Nevertheless, scientists are also looking for ozone, which can serve as an indirect indicator of oxygen and may suggest ongoing biological activity on the planet. Even these partial clues can contribute to the growing case for Proxima Centauri b's potential habitability. Despite its cutting-edge technology, the James Webb Space Telescope cannot study every promising exoplanet in the universe. It is limited by distance, angle, and observational timing, and thus, only a select group of nearby exoplanets fall within its observational reach. To address these challenges, scientists are preparing for the next generation of telescopic technology. Ground-based observatories, like the Extremely Large Telescope, ELT, set to become operational by 2028, will allow for even more refined observations. With its massive mirror and enhanced resolution, the ELT will be able to examine distant exoplanets with unprecedented detail, potentially capturing atmospheric spectra and surface features that elude current instruments. Looking further ahead, future space telescopes will be designed with specialized instruments that can block out the overwhelming light from host stars, enabling a clearer view of the planets themselves. These future missions aim to distinguish between gases created by living organisms and those generated through geological processes. It's a monumental scientific challenge, but one that researchers are determined to overcome. Even as technology improves and discoveries accumulate, the fundamental question remains: are we truly alone in the universe? Despite decades of research, hundreds of planetary discoveries, and tireless listening for alien signals, we still don't have a definitive answer. Yet, every step brings us closer. The lights on Proxima Centauri b might be the most promising hint yet. They remind us that the universe is vast, full of mystery, and perhaps full of other beings also gazing up at their own night skies, wondering. If someone is looking back, if you enjoyed this journey into the frontiers of space discovery, don't forget to like and subscribe for more exciting updates on the search for life beyond Earth. Thank you for watching, and until next time, keep looking up.